Welcome back, and this is the last in the series of videos looking at moles. In moles 1 we focused on solids, in moles 2 gases, and in this moles 3 we're going to be looking at solutions. Now, along with doing the calculations, you need to also be familiar with the practical techniques of making up a solution and doing a titration, and both of those we'll be doing in class. So in this videos I'm just going to be going through the calculations. So we're on page 2 of your notes, and you're also going to need a calculator. Now, a solution is formed when we dissolve a solute, that's the solid, in a solvent. Now, aqueous solutions, the solvent is always water, but there are other solutions you'll come across where we've dissolved things in organic solvents. But in this we're going to focus just on aqueous solutions. The first thing we need to be able to calculate is the concentration of a solution. Now, the concentration is normally given in moles per decimeter cubed. That's this units, so moles divided by decimeters cubed. This will be sometimes known as the molarity of the solution, so you need to look out for that word. Sometimes you'll always see it written as big M to stand for molarity. So a 1 molar solution can be written as 1.0 M, and that contains 1 mole in 1 decimeter cubed. So you need to learn this formula. Remember, in chemistry you're not given a formula sheet, so all these formulas have to be learnt. So from the units we can see that it's moles divided by the volume in decimeters cubed. Now, quite often we're not given the volume in decimeters cubed in titrations, we're given it in centimeters cubed, and that's why we have this 1000 term here. So the concentration is equal to the number of moles times by 1000 divided by the volume. But if you remember the units, that will help you work out the formula. So let's have a look at the first example. And I'm going to go through this in detail. Obviously this first one you can just do by sight, but it's important that you understand the steps in the calculations. So I have 2 moles of KOH in 1 decimeter cubed, and I'm working out the concentration. So the concentration is the number of moles, 2, times by 1000 divided by the volume in centimeters cubed, where there are 1000 centimeters cubed in a decimeter cubed, so it becomes 2 moles dm to the minus 3. In other words, 2 moles in 1 decimeter cubed. And we work the others out on that page in the same way. So number of moles times by 1000 divided by the volume in centimeters cubed. Sometimes you'll be asked to work out the concentration in grams per decimeter cubed. What you need to remember is that mass is equal to moles times RMM. So the grams per decimeter cubed is equal to the moles per decimeter cubed times the RMM, because these decimeters cubes just cancel. So, for example, we've got 1 mole of NaOH in 500 centimeters cubed, and we want to work out the concentration in grams per decimeter cubed. So the first thing I need to do is I need to work out the concentration in moles per decimeter cubed. So that's going to be 1, my number of moles, times by 1000 divided by my volume, which is 500, and that gives me 2 moles per decimeter cubed. Then I've got 2 times the RMM of NaOH, which is 40, which gives me 80 grams per decimeter cubed. I can do the same for the others, work out the concentration in moles per decimeter cubed, then times that by the RMM to give me the grams per decimeter cubed answer. So we need to get used to using these equations and being able to rearrange them. We use them to make up something called a standard solution. Now, a standard solution is one where we know the concentration to a high degree of accuracy. And in class, you're going to make up a standard solution of sodium chloride. And I'm just going to go through the calculations that you need to be able to do that. So our task is to calculate the mass needed to make 250 centimeters cubed of a 0.1 molar solution. So the first thing I'm going to do is work out the number of moles that actually relates to. And that's just a rearrangement of the first equation. So number of moles equals volume in centimeters cubed divided by 1,000 times the concentration. Again, if you think about it in terms of units, I've got my volume because I've divided by 1,000 in decimeters cubed times concentration, which is moles per decimeter cubed. Those decimeter cubes cancels and I just get moles on its own, which is what I'm looking for. So that's another way of helping you to remember that equation. Moles is equal to volume in decimeters cubed times the concentration. Because the volume is pretty much always given centimeters cubed, we just divide it by 1,000. So the number of moles needed in this case, well, I want a 250 centimeter cubed sample, and I wanted a concentration 0.1. So in other words, I need to weigh out 0.025 moles of my sodium chloride. The mass, if you remember back to the first pack, mass is moles times RMM. So that is 0.025 times the RMM of sodium chloride, which is 58.5, and that works out as 1.46 grams. So I know I need to weigh out 1.46 grams to make up a 250 centimeter cubed solution. So it's important that we understand the steps needed to make up our standard solution, and it forms one of your core practicals. So the first thing you're going to do is accurately weigh out a known mass of your solute. So we need to know exactly how many grams we're going to be dissolving. You can dissolve that in a small amount of solvent. Sometimes it'll need warming, not usually with the solutions that we're going to be using for titrations. You're then going to transfer that to a volumetric flask. Volumetric flask is a specific piece of kit designed to make up standard solutions. You're going to rinse all of the solution from your flask into your volumetric flask with more solvent, in this case with more water. You're going to very carefully make it up to the line. And I would suggest you do that with a dropping pipette, just so that you get the bottom of the meniscus absolutely on that line. So what you should see when you look at it from eye level, and it's important that you look at it from eye level, is there is the line on the neck of your volumetric flask, and the meniscus should just touch the line. So it should look like that if you're looking at it from that angle. Okay, so you need to be looking at eye level. If you look at too high or too low, that's going to distort it and you're not going to get the right value. The last thing you need to do, and it's a step that many students forget, is you need to stopper the flask and invert it at least 5 times in order to thoroughly mix your solution so that you don't get different layers of concentration. So it's one homogeneous solution. On the next page, there are 3 students' attempts at answering the question about how they should prepare a 250 centimeter cubed sample. So what we would like you to do is to pause the video at this point and mark them. There are 4 marks available, and I'll go through each answer individually in a moment. So having read the first student's response, it should be clear that this is a poor attempt at actually answering the question about how to do a titration. It's not actually answering the question about how to prepare a standard solution. So this scores 0. There are no pity marks in chemistry. Nothing in there is worth any marks, so it doesn't score any marks. The next student did slightly better. the student should weigh out a known mass of the ethanoic crystals. That gets a mark. He should then dissolve these in deionized water in a beaker. He should then transfer the solution into a 250 centimetre cubed flask. But there's a key word missing here, so he doesn't get that mark. They have gained a mark for talking about washing through and filling the flask up to the line. So that gets them the second mark. So in this student has scored 2 out of the 4 marks. If they'd completed this by including that very important word volumetric there, they would have scored 3 out of the 4 marks. The last example is the best out of the 3, however, it still only scores 3 out of the 4 marks available. So they've talked about dissolving the crystals with a small amount of water. What they've not mentioned is the first step, that they need to weigh out a known mass of the crystals. They have talked about the volumetric flask. They have talked about rinsing the beaker with distilled water and adding that and making up the solution to the 250 centimetre cubed mark on the volumetric flask. And they have talked about inverting the flask, making sure the mixture was thoroughly mixed. So in this last bit of the video, we're going to be looking at calculating concentration of solutions. So these are 2 of the equations that you need to know. You need to know that moles is mass divided by RMM, and that concentration is moles per decimetre cubed. So that's moles times by the volume in decimetres cubed, and we usually work that out by going 1,000 divided by the volume in centimetres cubed. So we're asked to work out the concentration of this HCl solution, hydrochloric acid. So the first thing I'm going to do is I'm going to work out the number of moles. Well, I've been given the grams, and that's 3.65, divided by the RMM of HCl, which is 36.5. So that gives me 0.10 moles, and the concentration is going to be moles 0.1 times by 1,000 and divided by the volume in centimetres cubed, which is also 1,000. So the concentration is simply 0.1 moles per decimetre cubed. And we can work out the rest of these in a similar manner. So we have mass divided by MR, which gives us moles. It's a good idea to keep this moles number in your calculator for the next step. And then it's times by 1,000 divided by the volume. And those are the same steps each time. So remember, these calculations need to be learnt. So concentration is moles times by 1,000 divided by the volume, or moles per decimetre cubed. So rearranging that equation, moles is equal to concentration times the volume divided by 1,000, where that volume is in centimetres cubed. If the volume has been given in decimetres cubed, it just becomes concentration times volume. So looking at this first example, we want to work out the moles. Well, moles is simply equal to our concentration, 0.5, times by the volume, 25 over 1,000. So that equals 0.0125. Doesn't matter what order I do that in, because it's all times. So we can also say moles is equal to the volume, 250 divided by 1,000 times the concentration, 0.25, and that gets me 0.0625 of a mole, and so on. So it's the same steps all the way through. If we're asked to calculate the mass in grams of the solute in each case, we just need to add on that final step of timesing the number of moles we just calculated by the RMM. So we do the first step, we work out the number of moles, exactly the same as we've done before. It's just now to find the mass, we're going to times through by the RMM. And again, same steps here. We work out the moles, and then to find the mass, we times the moles by the RMM. We could also use this method to find out the grams in our concentration in grams per decimeter cubed. So there are two ways of calculating this. We can work out the mass, we know the mass in 50 centimeters cubed, therefore we can find the mass in 1,000 centimeters cubed. Another way of doing this would be just to take the concentration which we're given, which is 0.5, times the RMM, which is 58.5, and that again equals 29.25. So there's two methods there. So that just takes us through the first few pages looking at the calculations in Moles 3 and how to make up a standard solution. You need to be able to describe the steps in the standard solution and do the associated calculations with it. And we're going to practice a lot more of these in class. So until then, take care, stay safe, bye bye.